Section 8.3, Quadratic Equations. Our essential question is, how do you factor a quadratic? And under our vocabulary, we have one vocab word. It's quadratic equation in standard form. A quadratic equation has a degree of 2. So standard form for a quadratic equation looks like this. It's very similar to standard form for a linear equation. Standard form for a linear equation was ax plus by equals c, like that. Standard form for a quadratic, this new equation is a quadratic because it has an exponent of 2. So it is not going to be linear. It's going to be nonlinear. Standard form is very specific, so you need to have your terms in order, from the highest exponent down to the lowest. So we start with the term with an exponent of 2, x squared, and then the next term has an exponent of 1, and then the last term does not have an exponent at all. A, B, and C are integers. And A should be positive. That's another similarity with our standard form for linear equations. Okay, so to factor these, what I want you to think about is, I want you to think about FOIL and think about how we got a quadratic for an answer, typically, when we used FOIL back in Chapter 7. So in Chapter 7 we did FOIL. I'm just going to write an example here. So for example, x plus 1 times x plus 3. FOIL, first terms will give me x squared. Outside terms, 3x. Inside terms, 1x. And last terms, 3 times 1, or 3. And then we would add them together. So when I say FOIL, we're multiplying. We're multiplying together two binomials. So we multiply the first terms, the outside terms, the inside terms, and the last terms, and then we add them together. So you may notice that the two terms in the middle, these two terms are like terms, so they can be combined. So if we combine them, we will get our answer, which would be x squared plus 4x plus 3. So the answer, when we multiply together two binomials, the answer is typically a trinomial. So we're going to work on factoring trinomials in this section. What we're doing is we're reversing the process. So instead of using FOIL to multiply binomials to get a trinomial, we are starting with the trinomial and figuring out what binomials multiply together to give us that trinomial. So we are factoring. So instead of multiplying together two binomials, we are factoring to find the binomials that would multiply to give us our trinomial answer. So what I want you to recognize is that when we multiplied together these first terms, they gave us our first term. When we multiplied together our last terms here, it gave us the last term. And when we multiplied together the outsides and the insides and combined them, we got the middle term. So the middle term comes from the outsides plus the insides, like that. So now I'm going to erase my FOIL work and take a look at the problem that we're on. So if my first term is x squared, I know my binomials have to start with x times x. If my last term is a positive 20, there are a few different ways I could get positive 20. 1 times 20, 2 times 10, or 4 times 5. So all three of those are options. All three of them. Knowing, though, that my middle term has to give me 9x, my middle term. So when I multiply together my outsides plus my insides, I have to get 9x. I think I'm going to try the 4 and 5 first. So plus 4 and plus 5. So x times x is x squared. So this one checks out. 4 times 5 is positive 20. That one checks out. Now, outsides, my outside terms, I get 5x. In my inside terms, here, I get 4x. If I add those together, I get 9x, my middle term. So I have correctly factored that trinomial. So my answer is x plus 4 times x plus 5. Okay, my next one. First term, last term, outside plus inside. Okay, what's different on this one, you may notice, is that there's a minus right here. So when I add together my outside and my inside terms, I have to get a -8, a -8. Starting my factors, the first term has to be x squared, so again it's x times x, that equals x squared. My last term has to be positive 12, so it could be 1 times 12, 2 times 6, or 3 times 4. Let's say I try one of those. Let's say I try 1 and 12. So I'm going to go with plus 1 and plus 12. So I could say 1 times 12, yes, that's 12. Now if I check my outside and inside terms, my outside terms would give me 12x, and my inside give me 1x. If I add those together, I get 13x. That is definitely not -8x. So 1 and 12, that's definitely not the way that my factors are going to work on this one. And to be honest, if I plug in positive 2 and 6 or positive 3 and 4, I'm still going to end up with a positive here when I add together the outsides and insides. So the only way to get a negative on that middle term here is going to be to recognize that I need to use the product of two negatives here. Because negative times a negative is also a positive, to give me the positive on this 12. And to get them to add to a negative in the middle, I'm going to have two negatives. So I am going to erase this part right here. And I am going to look at those negative factors, and I'm going to try some of those negatives. To get -8, maybe you want to use -3 and -4. So I'm trying this one. We already know the positives are out. -4x and then -3x add together to give me -7x. So I'm close, but not quite at the -8x that I need. So this one doesn't work. Next, I'm going to try the 2 and the 6. So -2, -6. Inside is -2x. Outside, -6x. If I add those together, I do get -8x, my middle term. So the correct factors, the correct binomials, would be x minus 2 and x minus 6. You can always FOIL to check and see if you factored it correctly. Okay, the next one, I need to do a little rearranging because I've got to have this in the correct order. My first term, second term, third term should look like this. Now I can factor. You always want to start out in standard form. So this one I'm done with. This one I'm going to work with. So first term, x times x. Last term, outside plus inside. -18 could be -18 times 1, -1 times 18, -2 times 9, -9 times 2, -3 times 6, or -6 times 3. Lots of factors to try out here. Now, some of you are maybe kind of getting the hang of this. So to get this -7 for my middle term, -7, I don't think I'm going to have 18 and 1 work. I'm going to try the 2 and 9. So -2 plus 9. X times x is x squared. -2 times 9 is -18. Inside, -2x. Outside, positive 9x. If I add those together, I get 7x. The only thing wrong is that I needed a -7x, not a positive 7x. So this one doesn't work, and I'm pretty sure this one is going to work for me. So I need a positive on my 2, and I need a negative on my 9. So if I put the negative on my 9 instead, and the positive on my 2, it will make positive 2x here, and negative 9x here. So we'll put a negative on that 7x. So I have correctly factored it. So my factors are x plus 2 and x minus 9. Next one is in the wrong order again. So I need to start with the x squared, then the 2x, and my last term is the -15. So my first terms, x times x, x squared. My last term here is a -15, so -1 times 15, -15 times 1, -3 times 5, or -5 times 3. To give me a 2 in the middle, I don't think I'm going to use the 15. It's going to be the 3 and 5. So let's try the -3 and the plus 5. -3 times 5 is -15. Outside, 5x. Inside, -3x. Add those together. -3 plus 5 is 2x. So, successfully factored. X minus 3 times x plus 5. Now we're going to use factoring and the zero product property to actually solve our quadratics. The solutions to a quadratic sometimes are called zeros, and other times they're called the x-intercepts. So they happen to represent where your graph, where your quadratic goes through the x-axis. So if I factor this, first, outside plus inside, and last, x times x is x squared, -18. So -1 or -18, -2 or -9, -3 or -6. 6 choices we have here. Which one is going to give us the outside plus inside equal to 3? I think it's going to be one of these because 6 and 3 happen to be 3 away from each other. So -3 plus 6. -3 times 6 is -18. Inside, -3x. Outside, positive 6x. Add these together, I get 3x. Perfect. Now, we are not quite done on this problem. We have factored it correctly. So here are the factors. But remember that the zero product property says that we need to solve each of those. So what if x minus 3 equals 0? That means x equals 3. So 3 is one of the x-intercepts. And what if x plus 6 equals 0? I'd subtract 6. So x equals -6 is the other x-intercept. So what this means is, if you were looking at a graph of this quadratic, it means that you have intercepts here and here. So your graph is going to be something like that, like a quadratic, where it goes through at 2 spots on your x-axis. Okay, the last one. First thing I need to do is make sure that we've got everything on one side. So I've got to move that 27 by subtracting it. so that we were written in standard form, you have to have everything on one side of your quadratic and in correct order for standard form. Because the other side has to have a 0 in order for the zero product property to work. So x squared, x times x. Negative 27 could be negative 1 and 27, negative 27 and 1, negative 3 and 9, negative 9 and 3. And that's it. To get a positive 6, I'm pretty sure it's going to be negative 3 and positive 9. So, negative 3 times positive 9 is negative 27. X times 9 is 9x. Negative 3 times x, negative 3x. Add those together, 6x for my middle term. So it's perfect. So now, I've got my factors, and it equals 0. So I need to solve each one using the zero product property. Set this one equal to 0, set the other one equal to 0, and solve. So x equals 3, and x equals negative 9 are the solutions. So the extra step, when you see the equal sign, you're not just factoring a quadratic, you have to actually solve for x. So the factoring part means figuring out the binomials, like reversing FOIL, but the equals 0 part means you've got to do one extra step with the zero product property and actually find the zeros or find the solutions. So when you see the equal sign, do the extra step. You should be able to write your summary now. And here are your homework problems to work on.